This is SpaceTime Series 29, Episode 43, for broadcast on the 10th of April 2026. Coming up on SpaceTime, climate change now slowing Earth's spin at an unprecedented rate, magnetic waves discovered deep inside the Sun, and that mystery medical evacuation from the International Space Station earlier this year finally explained. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that climate change is slowing Earth's rotation at an unprecedented rate compared to the past 3.6 million years. A report in the Journal of Geophysical Research has found that climate change is lengthening Earth's day because rising sea levels slow Earth's rotation, increasing the average length of a day by 1.33 milliseconds per century. The authors reconstructed ancient day-length fluctuations using fossil remains of single-cell marine organisms known as benthic foraminifera. An exact 24-hour day is not a given. The length of day changes due to gravitational effects of the Moon, as well as numerous geophysical processes on Earth acting within its interior, its surface, and in the atmosphere. But today's climate change also affects the length of the day. Previous studies by the same researchers had already shown that between the years 2000 and 2020, an average Earth day had lengthened by a rate equivalent to 1.33 milliseconds per century due to climate change-related factors, especially the redistribution of continental ocean mass due to the melting of polar ice sheets and mountain glaciers. The new study builds on that, showing that this now is happening faster than at any previous time over the past 3.6 million years. One of the study's authors, Mustafa Kiani-Shavanti from the University of Vienna, says the planet spinning causes centrifugal force to move more water towards the equator, and that slows down the planet's rotational rate. It's exactly the same as figure skaters who spin more slowly once they stretch their arms out and move more rapidly once they bring their hands closer to their bodies. But what remained unclear until now was whether there were earlier periods when climate increased the length of a day at a similarly rapid pace. To answer that question, Shavanti and colleagues used the fossilized remains of benthic foraminifera. The chemical composition of these fossils allows scientists to infer sea level fluctuations and then mathematically derive the corresponding changes in day length. But to draw more robust conclusions, the authors also used a probabilistic deep learning algorithm, a physics-informed diffusion model, which captures the physics of sea level change while remaining robust to the large uncertainties inherent in paleoclimate data. The growth and melting of large continental ice sheets repeatedly cause significant day-length variations through sea level changes. Shavanti says that compared to values from the 21st century, however, it's clear that today's increase in day length stands out in the climate history of the past 3.6 million years. Only once, around 2 million years ago, did the rate of change in the length of a day even come close to the current rate. The authors say that by the end of the 21st century, climate change is expected to affect the length of a day even more strongly than the Moon. Now, although these changes are only in milliseconds, they can cause problems in many areas, including timekeeping and navigation, which requires very accurate information on Earth's rotation. This is SpaceTime. Still to come, magnetic waves discovered deep inside the Sun, and that mystery medical evacuation from the International Space Station back in January has finally been explained. All that and more still to come on SpaceTime. Scientists have detected large-scale magnetic waves moving deep inside the Sun. The discovery, reported in the journal Nature Astronomy, could help scientists predict solar activity. The waves, which are driven by powerful magnetic fields far below the solar surface, provide a new window into parts of the Sun that are otherwise inaccessible, thereby giving astronomers a new tool to study how our local star's magnetic field is formed and how it evolves over time. The Sun's interior is the dynamic ocean of hot, electrically charged gas known as plasma, which is shaped by rotation and magnetic forces. These magnetic fields drive the sun's 11-year solar cycle, sunspots, and powerful eruptions such as solar flares and coronal mass ejections, which can disrupt satellites, communication and navigation systems, and affect power grids on the Earth. Until now, the magnetic behaviour deep inside the sun was largely hidden from observation. But in this new study, scientists from New York University analysed more than a decade of the sun's natural vibrations, a process known as helio or stellar seismology. Their work revealed evidence of previously undetected global-scale magnetic waves influenced by the sun's internal magnetism. By measuring how these waves move, the authors can infer the strength and structure of magnetic fields deep below the sun's surface. So, the findings are providing a new approach for studying the sun's interior and its magnetic evolution over time, with implications for improving space weather forecasting as well as understanding magnetic activity in other stars throughout the universe. This is SpaceTime. Still to come, that mystery medical evacuation from the International Space Station earlier this year has finally been explained. And the splendours of the Southern Cross and its two pointer stars Alpha and Beta Centauri, the supergiant Canopus, and the Lyrids meteor shower are among the highlights of the April night skies on Skywatch. Well, it seems that medical evacuation from the International Space Station earlier this year has finally been explained. At the centre was four-time NASA astronaut Michael Fink. Apparently, he suddenly fell ill while eating dinner after preparing for a spacewalk. He couldn't talk and remembers no pain, but after seeing him in distress, his crewmates requested help from flight surgeons on the ground. Fink says it came completely out of the blue and was amazingly quick. The 59-year-old retired Air Force colonel says the episode lasted about 20 minutes and he felt fine afterwards and still does today, and he's never experienced anything like that either before or since. Doctors have ruled out a heart attack. Fink and his fellow SpaceX Crew 11 Expedition 74 astronauts were some 5.5 months into their stay aboard the International Space Station when the episode occurred. The space station's ultrasound machine was initially used in orbit, and then follow-up tests were conducted when he returned to Earth. NASA are now poring through other astronauts' medical records to see if any similar events may have affected other crew members. Although it's not uncommon for astronauts to get sick in space, this was the first time ever that a medical emergency evacuation had to be carried out from the International Space Station. This is SpaceTime, and Skywatch is next. And time now to check out the night skies of April on Skywatch. April is the 4th month of the year in the Gregorian calendar and the 5th in the early Julian calendar. The Romans gave this month the Latin name Aprilis. Although the name's origins aren't certain, traditional etymology suggests it's from the verb aperire, to open, as in it being the season when the trees and flowers begin to open as the northern hemisphere moves into spring. April is also Prevention of Cruelty to Animals Month, and so it's a good time to consider adopting a shelter pet or donating to an animal welfare charity. High in the southern sky during April, you'll find the Southern Cross and its two pointer stars Alpha and Beta Centauri. The more distant of the two pointer stars from the Southern Cross is Alpha Centauri, which also happens to be the nearest star system to our own. Located some 4.3 light-years away, Alpha Centauri actually consists of 3 stars. There's Alpha Centauri A and B, which orbit each other, and Proxima Centauri, which orbits the pair. And at 4.25 light-years distant, is currently the nearest star to the Earth other than the Sun. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It's slightly bigger, having about 1/10 more mass than the Sun, and has about 50% more luminosity. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are spectral type M red dwarf stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral to represent luminosity. So, our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars called brown dwarfs. These are sometimes born as spectral type M red dwarf stars, but become brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Orbiting in a binary system with Alpha Centauri A is Alpha Centauri B, a spectral type K orange dwarf star, a little smaller and cooler than the Sun, with about 0.9 times the Sun's mass and about half its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years. The distance between the two stars varies between roughly that of Pluto and the Sun and that of Saturn and the Sun. The third star in the system, Proxima Centauri, sometimes called Alpha Centauri C, is a spectral type M red dwarf star, with roughly a seventh the diameter and about an eighth the mass of the Sun. It takes around 550,000 Earth years to orbit Alpha Centauri A and B. The nearer of the two pointer stars to the Southern Cross is Beta Centauri, also a triple star system, but this one located a far more distant 390 light-years away. All three are massive young blue stars, far larger and more luminous than the Sun. Two of the stars, named Beta Centauri AA and Beta Centauri AB, orbit each other, while the third star, Beta Centauri B, orbits the primary pair every 1500 Earth years. Beta Centauri AA and AB are known as a spectroscopic binary, orbiting each other every 357 Earth days. Spectroscopic binaries are double-star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our point of view here on Earth at least, by their spectroscopic signatures. Both these stars are now reaching the end of their time on the main sequence and will soon run out of the core hydrogen they use for fusion, the process which makes stars like the Sun shine. The two pointer stars, Alpha and Beta Centauri, are named after Chiron, the centaur, a mythological Greek being half man, half horse. Chiron taught many of the Greek gods and heroes, but was placed among the stars after accidentally being shot with a poisoned arrow by Hercules. Next to the pointer stars is the spectacular Southern Cross, or Crux, the smallest but one of the best known of the 88 constellations in the sky. The Southern Cross is considered an important constellation for navigation and is featured on the flags of several nations, including Australia, Brazil, New Zealand, Papua New Guinea and Samoa. In April, the Southern Cross lies on its side in the early evening, but becomes more and more upright as the night progresses. The bottom and brightest star in the Southern Cross is Alpha Crucis, or A Crux, which is actually a multiple star system located 321 light-years away. It consists of three stars, A1 Crucis, which is a spectroscopic binary, and A2 Crucis. A2 Crucis and the primary star in A1 Crucis are both spectral type B blue stars, with surface temperatures of 26,000 and 28,000 Kelvin respectively. The two components orbit each other every 1500 Earth years at an average distance of around 430 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres or 8.3 light minutes. The spectroscopic binary A1 Crucis is thought to comprise two stars, with about 10 and 14 times the mass of the Sun respectively. The pair orbit each other every 76 Earth days at a distance of around 150 million kilometres, in other words, one astronomical unit. The masses of A2 Crucis and the larger component of A1 Crucis are expected to eventually explode as core collapse supernovae, ending up as neutron stars. while the smaller component of A1 Crucis could survive as a white dwarf. The left-hand and second brightest star in the Southern Cross is called Beta Crucis, and it's also a spectroscopic binary, consisting of two stars orbiting each other every 5 Earth years, at an average distance which varies between 5.4 and 12 astronomical units. Beta Crucis is located some 280 light-years away. The primary star, Beta Crucis A, is a spectral type B Beta Cephei variable blue star, which changes in brightness over a period of around 4 to 4.5 hours. It has about 16 times the Sun's mass, about 8 times its diameter, and a surface temperature of some 27,000 Kelvin. By comparison, our Sun has a surface temperature of just 6,000. The second star in the system, Beta Crucis B, has about 10 solar masses. A third companion has also been detected in the system. However, it appears to be a low-mass pre-main sequence star which hasn't yet commenced nuclear fusion. Near Beta Crucis is the spectacular young open star cluster known as the Kappa Crucis cluster, or NGC 4755, and more commonly referred to as the Jewel Box, the name given to it by famous 18th century astronomer John Herschel. Open star clusters are groups of stars which were originally all born at the same time out of the same collapsing molecular gas and dust cloud. Although somewhat still gravitationally bound to each other, stars in open clusters eventually separate, moving to other parts of the galaxy. As the name suggests, the Jewel Box is a stunning collection of more than 100 bright, colourful stars, located some 6,440 light-years away, although its exact distance is somewhat difficult to determine because of the nearby Coalsack Nebula, which obscures some of the light. The Coalsack is a dark nebula containing lots of gas and dust blocking out background stars. In Australian Aboriginal Dreamtime legend, the Coalsack forms the head of the Emu constellation, with the dark dust lanes of the Milky Way forming the emu's body and legs. The central parts of the Jewel Box are framed by bright stars making up an A-shaped asterism. These are among the brightest known blue, white and red supergiants in the Milky Way. Gamma Crucis, which is located at the top of the Southern Cross, is the third brightest star in the constellation. It's also one of the nearest red giants to our solar system, located just 88.6 light-years away. Although only 30% more massive than the Sun, its expanded outer envelope is bloated out to some 84 times the Sun's radius, and is radiating some 1,500 times more luminosity than the Sun. As a red giant, no longer on the main sequence, Gamma Crucis is nearing the end of its life. Its surface temperature is some 3,626 Kelvin, and it has a prominent reddish-orange appearance. The star on the right-hand side of the Southern Cross is Delta Crucis, a massive, hot and rapidly rotating star that's in the process of evolving into a red giant and will eventually end up as a white dwarf, the stellar corpse of Sun-like stars. Delta Crucis is located some 345 light-years away and has about 9 times the Sun's mass and 8 times its radius. It's presently radiating at around 10,000 times the luminosity of the Sun at an effective temperature of 22,570 Kelvin, causing it to glow with a blue-white hue. The smallest star in the Southern Cross is Epsilon Crucis, which is located in the space between Delta and Alpha Crucis. It's a red giant, some 228 light-years away. It has about 1.42 times the mass of the Sun and about 32 times its radius. Its surface temperature of 4,148 Kelvin means it's sometimes referred to as an orange giant. The Southern Cross is at its highest point in the southern sky this time of year and is pointing directly at the southern celestial pole. It's within the constellation Centaurus the Centaur, the half-man, half-horse of Greek mythology we mentioned earlier. The creature is holding a bow loaded with an arrow. The Centaur's front leg is marked by the 2 pointer stars Alpha and Beta Centaurus. His back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster visible with the unaided eye from dark locations. Unlike open star clusters, globular clusters are tightly packed spheres containing thousands to millions of stars, which were originally all thought to have been born at the same time from the same molecular gas and dust cloud. Omega Centauri is about 16,000 light-years away. It's one of the largest and brightest of the hundreds of globular clusters known to orbit around the Milky Way galaxy. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. The constellation Orion the Hunter is still clearly visible in the northwestern sky this time of year, with its rectangle of 4 stars surrounded by a central trio of stars which form Orion's belt. To the right or east of Orion is the constellation Gemini and its 2 brighter stars, Pollux and Castor. This time of year, the Gemini twins are almost directly due north for southern hemisphere sky watchers. The higher of the 2 stars, Pollux, is a red giant, some 11 times the diameter of the Sun and located just 34 light-years away. The other star, Castor, is much further away, some 51 light-years. Look to the east and you'll see the star Regulus, the brightest star in the constellation of Leo the Lion. Regulus, which means Little King, is located 77 light-years away, and it's about 3.5 times as massive as the Sun and about 140 times as luminous. Regulus is a binary companion star, which takes 130,000 years to orbit the primary. To the right of Regulus, and virtually due east in the sky right now, is the star Spica. Located directly below the 4 stars in the constellation Corvus the Crow, Spica is the brightest star in the constellation Virgo. Also known as Alpha Virginis, it's the 16th brightest star in the night sky, and is another spectroscopic binary, comprising 2 stars closely orbiting each other every 4 Earth days. In fact, the 2 stars in Spica are orbiting so close together that the gravitational interaction between them has caused them to become rotating ellipsoidal variables, distorting them into the shape of a rugby league or gridiron football. Light from this binary changes in brightness as the 2 stars orbit each other, exposing their elongated hemispheres to us. Spica is located some 260 light-years away and is some 2,000 times as luminous as the Sun. Spica means ear of wheat, which Virgo is holding in a hand. It's so named because it marks the start of the harvest season in the Northern Hemisphere. The primary is a blue giant variable Beta Cepheid, which undergoes small rapid variations in brightness because of pulsations in the star's surface thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7.5 times its diameter. Once a spectral type B blue-white main sequence star, it's now pulsating rapidly, rotating at more than 199 kilometers per second over a 0.1738 Earth-day period. It's one of the nearest stars to the Earth, which is expected to end its life as a Type II core collapse supernova. The second star in the system is also thought to be a spectral Type B blue-white giant, about 7 solar masses and 3.6 times the Sun's diameter. Okay, going back to the Southern Cross and looking to the right or west, you'll see the star Canopus. It's the second brightest star in the night sky after Sirius. Even though Canopus is 312 light-years away, it looks incredibly bright because it's huge, 100 times the diameter of the Sun and 10,000 times as luminous. This year's second major meteor shower, the Lyrids, will peak on April the 22nd and 23rd. The Lyrids appear to radiate out from the constellation Lyra, close to the star Vega, one of the brightest stars in the sky this time of year. The source of the meteor shower are particles of dust and debris shed by the long-period comet C1861 G1 Thatcher. Sky watchers in the Northern Hemisphere get the best view of the Lyrids. However, listeners at mid-Southern Hemisphere latitudes can also see the shower between midnight and dawn. Patient observers will be rewarded with around 18 meteors per hour before dawn from dark sky locations. And joining us now for the rest of our tour of the April night skies is senior science writer and Sky and Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Well, it's April, so after nightfall in April, we've got the Milky Way, which can be seen spanning the sky from horizon to horizon. Or, at least, I'll start that again. I'm going to start the whole thing again. G'day, Stuart. Well, yes, after nightfall on April evenings, we've got the Milky Way, which can be seen spanning the sky from horizon to horizon, or at least it does. You can see it if you're lucky, because it depends on what your local light pollution situation's like. So for where I live, in the suburbs of a big city, I can't actually see the Milky Way. I cannot see the glow of our galaxy seen from the inside, which is what the Milky Way is, our view of our galaxy from the inside.
I used to work in Darwin in the Northern Territory at the local radio station there, and I used to live in Sydney, so I'd go down for holidays to Sydney and drive between the two, which is about, I think, 4,500 kilometres, which is a long drive. And so I didn't get to see the Milky Way until I was in the Australian outback, where there's no lights other than what the sky provides. Then it is spectacular.
Yeah, if you're away from sources of light pollution, you can see the Milky Way, and it's amazing. But for so many people who live in the city, myself included, just cannot see the thing because of the light pollution. It's really, really bad. But, if you're lucky and you do live in a darker location, or you're going on holidays or driving through the outback or whatever, you should be able to see it at this time of year, stretching across the sky from the southeast to the northwest. But even if you can't see the glow of the Milky Way, you can still trace its path by virtue of some of the bright stellar signposts along its length. These are the bright stars that can be seen even under the worst light pollution scenarios. You can't see the faint glow of the Milky Way, which is the accumulation of millions and millions of stars that you can't make out with the naked eye. But there are certain bright stars in the constellations along the length of the Milky Way. You can always see them. So starting way down in the south, as we can see from down the southern part of the planet, from below the equator, we've got Alpha and Beta Centauri. And they're a pair of stars known as the pointers. That's because if you draw a line between the two of them and extend it onwards, that line points roughly to the next collection of brightish stars, which is the constellation of the Southern Cross. The Alpha and Beta two-pointer stars, they are the 3rd and the 11th brightest stars in the night sky, Alpha and Beta, 3rd and 11th brightest stars. And the two brightest stars in the Southern Cross are the 13th and the 20th brightest. Now, moving further along the Milky Way, and a little off its right-hand edge, is a star called Canopus. This is the brightest star in the constellation called Carina, and it's actually the 2nd brightest star in the whole night sky. And if we go still a little bit further along, we come to the brightest star in the night sky. That's Sirius, which is the so-called dog star, because it's the brightest star in the constellation of Canis Major, which is the larger or greater dog. So Venus, you've got the 2nd brightest star, and just a little further along, you've got the brightest star in the night sky. And not far away from that is another star called Procyon, a little bit further along the Milky Way. This is the brightest star in Canis Minor, the lesser or smaller dog constellation. And it's the 8th brightest star that we can see from Earth. Then we go a little bit further along the Milky Way again, and we've got the 2 bright stars in the constellation Orion. You've got Betelgeuse, the sky's 10th brightest star, and Rigel, the 7th brightest star. I think it's really interesting to note that all but one of those stars that I've just mentioned, that they seem to be single stars. You look up in the night sky and they just look like a star. Almost all of them, in fact, all but one, in fact, multiple star systems. So you've got Alpha Centauri and Beta Centauri, and they are both triple star systems. The Alpha star in the Southern Cross is a 7-star system. It's got 7 stars, while its sibling, the next brightest star in the Southern Cross, Beta, is a triple star. You've got Sirius and Procyon are both binary stars. Betelgeuse is a binary, and Rigel has at least 4 stars in its system. So out of all the stars we've just gone through along the length of the Milky Way that you can see in the night sky during April, at least in the evening, of all those ones I mentioned, only Canopus is a single star. And this actually is pretty typical of the situation out there in space. Multiple star systems are the norm. So stars like Canopus, stars like our Sun, solar stars, they're not rare. I'm not trying to say they're rare, but I guess you might call them the exception. A lot of stars out there are multiple stars. They don't seem like that to the naked eye, but some of them you can get even a small telescope onto them, like Alpha Centauri. You can get a small telescope onto that, and you can see that it's 2 main stars. There is a 3rd tiny one called Proxima Centauri that is very faint, and you have to know exactly where to look for it in a bigger telescope. But some of these stars you can see their double or triple nature if you get a telescope on them. Anyhow, that's the little tour of the Milky Way. Let's go closer to home now and look at what the planets are doing this month. As darkness begins to fall, there are 2 planets visible in the evening sky. Hovering above the western horizon is Venus. It's bright, certainly, but it's a bit lost within the twilight glow, the sunset glow, at least before the first half of April. For the second half of the month, it's pretty much in the same spot in the sky, but because the sun is setting a little bit earlier each night, the sky is a bit darker. So Venus is slightly darker sky background, so it makes it a bit easier to see. The other bright star lighting up the evening sky is Jupiter. It forms a nice triangle with 2 of those stars I mentioned earlier, Procyon and Betelgeuse. But the big thing, the main planetary action happening this month is in the pre-dawn sky, so you've got to be up early. If you're up around about 5 o'clock in the morning, morning Australian Eastern time, whatever that works out to be in your time zone. If you're up there, have a look above the eastern horizon, not too far up, just above the eastern horizon. You should see what looks like 3 stars in a row going vertically up the sky. They're actually 3 planets, starting from the lowest one and going upwards. We've got Saturn, Mars, and Mercury. So that's pretty cool to see 3 planets all in a row close to the horizon. But if you keep watching as each day goes by, you'll see them, in fact, I was going to say slowly, but quite rapidly slide towards each other. So much so that from the 19th to the 22nd, they'll be really quite super close. A little tight triangle, only about 3 or 4 moon spans apart. It's going to look really spectacular. There'll be probably people ringing up radio stations saying, what's that little collection of lights I can see out in the sky there? If you've got a pair of binoculars, a small telescope, it'll be a really, really great view. But if you don't have that, just own eyes is fine. Go out about 5 o'clock in the morning between the 19th and the 22nd. Look to the east, straight to the east where the sun's going to come up. And you'll see this tight little triangle of 3 dots of light, and that'll actually be planets Saturn, Mars, and Mercury. I have to say, Stuart, I'm not really a good one for getting up early in the morning, but I'm going to make an exception in this case. I will be getting up to have a look at this, fingers crossed, with the weather.
I think
this
my
one's going to look
policy
really
on
nice.
getting up early in the morning.
I think the morning doesn't really exist for you, does it?
Nope, that's when you come home.
It's when you come home. But you have disc going all night. Do they still have discos? Or are we showing our age?
It's called clubbing.
Clubbing. See, again, showing my age. And that, Stuart, is the 9th of April.
That's senior science writer and Sky and Telescope magazine contributor Jonathan Nally, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.